I gave one real engineering problem to 4 different AI models, and then I graded each one, exactly like a student sitting an exam. There is one correct textbook answer, but there are 4 very different roads to reach it, and not every road actually arrives. So who really gets there, and who only looks like they do? Let us find out. Not long ago, solving a problem like this meant a slow, scattered hunt. You would reopen the textbook and your lecture notes. You would search the web, then bounce between Chegg and Course Hero for paywalled step-by-step solutions. Wikipedia for the theory, YouTube for a worked example, and Stack Exchange, Quora or Reddit, hoping someone had already asked it. Slow, scattered, and usually behind a paywall, and you still had to verify it all yourself. Then AI changed the question entirely. Why search for the answer when you can simply ask for it? So here is the question. It is a classic from Rao's mechanical vibrations. Find the torsional stiffness, the torsional spring constant, KT, of a steel propeller shaft, and the whole challenge is hiding inside figure 1.30. The shaft is not a simple solid rod. It is hollow and it is stepped. 2 separate sections, each with its own outer diameter, inner diameter, and length. Read those dimensions correctly off the drawing, and the rest is just careful, methodical arithmetic. Miss them, and everything downstream falls apart. The contestants. 4 models, the same figure, the same question, no hints, no clarifications, and no second attempts. First, DeepSeek, the open-weight challenger. Then Gemini, Google's multimodal flagship, ChatGPT, the household name, and Claude, the careful step-by-step reasoner. 4 contenders, 1 drawing, 1 shot each. But a right number is not the whole story. So I am scoring each model out of 100 on 5 things. 25 points for correctly reading the figure, 25 for a sound, valid method, 30 for landing on the correct answer, 10 for clear, sanity-checked working, and 10 for plain honesty, for flagging any assumption it had to make. Method matters as much as the result, so watch closely who actually earns it. First up, DeepSeek. Here is exactly how it works in real time. I drag the question straight in as an image, and then I type the request. And I keep it deliberately simple. Solve the question step by step. No hint about the shape, no extra context, nothing to lean on. Then I just let DeepSeek run and watch how it works through the problem from there. And DeepSeek is honest from the very first line. It says outright that it cannot actually see figure 1.30, so it falls back on the textbook method it does know. Torsional stiffness equals G/J over L, the shear modulus, times the polar moment of area divided by the length. It even lays out both possible cross-sections, the formula for a solid shaft and the formula for a hollow one, which subtracts the inner bore. The theory is perfect, but without ever seeing the figure, it has no way of knowing which of the two the real shaft actually is. So it does something subtle, but fatal. It invents its own numbers just to illustrate the method. A single solid shaft, 50 millimeters across, 1.5 meters long. It runs that math cleanly and confidently and arrives at 32,700 Newton meters per radian. A flawless answer for a shaft that exists nowhere except its own example. A flawless recipe for a problem it was never actually given. And it even signs off by admitting it. Tell me the real dimensions and whether the shaft is hollow or solid, and I will give you the exact answer. It knew what it did not know. It just never saw the figure. On the rubric, that is 30 out of 100. It was honest, and it clearly knew the formulas cold, but it never read the actual problem. So its only number is a generic stand-in, strong on honesty, empty on the answer. Next, Gemini. Same figure, same question, now handed to Gemini. I upload the exact same drawing and type the exact same instruction. Solve it step by step. Watch how differently this one begins. Start with analyzing the problem. It takes some time to initiate, the defining the components. Precision text undertaken, then the solution is generated. And straight away, Gemini does the one thing DeepSeek could not. It reads the figure. Two hollow sections, joined in series, and it pulls the real outer diameters, inner diameters, and lengths directly off the drawing. The inputs are right. It reaches for the hollow polar moment of area, subtracting the inner bore, works out the stiffness of each segment, and recognizes that the two sections act as torsional springs in series. Then it runs the numbers, expressing each section's stiffness in terms of G, the shear modulus, and combining their compliances the way that series springs demand. It plugs in steel for G and lands on 6.6 times 10 to the 6th Newton meters per radian. And then it does something I love. It sanity checks itself. The combined system has to be softer than its softest single segment, exactly as springs in series must be. And it is. Gemini, full marks, a clean 100 out of 100. Right inputs, right method, right answer, and checked. Now ChatGPT. The very same prompt, the very same image, this time to ChatGPT. Same instruction. Solve it, step by step. Let us see where this one goes. Start with analyzing image. Only need a short period to produce the output. ChatGPT takes the same honest route as Gemini. It reads the figure correctly, identifies both hollow sections, and sets up their polar moments the right way. It carefully works out each section's polar moment of area and its stiffness, all expressed in terms of the shear modulus. Then it adds the two segments together in series, combining their compliances exactly by the book. Substitute steel, and it arrives at 6.6 times 10 to the 6th Newton meters per radian. Right on the money. ChatGPT, 98 out of 100. Near perfect. It just showed a little less of its rigor and checking along the way. And finally, Claude. One more time, the same figure, the same question, now to Claude. Identical image, identical instruction. Watch how this one reasons it out. Just type solve the question step by step, dissecting propeller shaft mechanics and dimensions. It took a while to process it, then produce the output. Claude reasons out loud, almost like a tutor. It pictures the shaft physically, running from the fixed wall out to the propeller, two hollow segments meeting in the middle, each one twisting like a spring, the two acting together in series. It writes down the two formulas it needs, the stiffness relation and the hollow polar moment of area, and then computes J for each of the two segments. And here is its signature move. Instead of staying abstract, it works out each segment's actual numerical stiffness in Newton meters per radian. Then it combines them with the product over sum rule for springs in series, landing on 6.6 times 10 to the 6th Newton meters per radian, and it explains the why at every single step. Claude, full marks, another clean 100 out of 100. So let us line all four up side by side. Now the truth. The textbook answer is 6.5997 times 10 to the 6th Newton meters per radian. Gemini, ChatGPT, and Claude all land right on it. And DeepSeek, 32,700, roughly 200 times too low. Not because its math was bad, but because it never saw the shaft it was supposed to solve. And here is the real lesson. DeepSeek's math was genuinely flawless. What failed was what it could not see. The real shaft is hollow and stepped, but DeepSeek quietly solved a generic solid shaft instead, a textbook stand-in that simply was not the part being asked about. And that is the whole point. AI usually does not fail at the math, it fails at what it cannot see. But was that just a fluke? So round 2, a brand new problem. Find the equivalent vertical stiffness of a crane, with its boom and its cable flexing together as one system. Same 4 models, the same image, and the same rubric. Let us see if the pattern holds. Gemini and Claude nail it again, 26.4. DeepSeek is off once more, but this time even ChatGPT drifts, 25.5, about 3.5% low. And that tells you something important. Correct is not actually binary. There are degrees of right. So who wins? Judged on both the answer and the working, across both rounds, the champions are Gemini and Claude. Perfect, twice over. ChatGPT is a very close runner-up, undone only by that round 2 drift. And DeepSeek comes last, not for bad math, but for never seeing the figure. 3 models nailed round 1, only 2 stayed perfect when the problem changed. So remember this, AI does not fail at the math. It fails at what it cannot see. So verify the inputs, not just the answer. Because a perfect solution to the wrong problem is still completely wrong.